Welcome, Math 20-1s. We're going to look at solving quadratic equations today. We'll eventually get to the quadratic formula, but we're going to do some preliminary stuff first. Let's solve the following quadratic equations. X squared equals 49. Well, to solve this, we want to take the square root of both sides. Square root of x squared is x. And remember, anytime you take the square root of something, you should include the positive and negative. So square root of 49 is 7. Positive and negative 7 will be the solutions to this quadratic equation. I'll do the same thing for the next one then. Take the square root of both sides. The square root of x plus 4 all squared is x plus 4. The square root of 9 is plus and minus 3. And now we're going to minus 4 for both sides. And we get two solutions for x. Negative 4 plus 3 is negative 1, or negative 4 minus 3 is negative 7. We got two solutions for the first one. We've got two solutions for the second one. We should probably have two solutions for this third one. Let's start by adding 8 to both sides. So we get 2x squared equals 48. Divide both sides by 2. And take the square root. Don't forget the plus and minus. Recall that the square root of 24 is an exact value, but it's not in simplest radical form. So what we want to do here is find a factor of 24 that's a perfect square, and rewrite that as the square root of 4 times the square root of 6. So our two solutions here should be x equals plus or minus. Square root of 4 is 2. There is no square root of 6. That's our solution for this question. Plus or minus 2 radical 6. If I look at our last example, I can't isolate the x term, as I've got an x squared and an x. If I set the equation equal to 0 and try factoring like we learned last lesson, there are no two numbers that add to negative 7 multiply to 11. The only factors of 11 are 1 and 11. They will never add or subtract to negative 7. So we can't factor it. We can't isolate x and solve it the way we did the other three. We have to learn another method. That other method would be called completing the square. In order to complete the square, we have to remember what a perfect square trinomial is. So, if you're asked to factor x squared plus 6x plus 9, we know the factors are x plus 3 times x plus 3, or x plus 3 all squared. So x squared plus 6x plus 9 is a perfect square trinomial. It factors as a binomial squared. Depending on what the middle term is, positive or negative will depend whether it's going to be a positive binomial squared or an x minus a negative squared. Note the relationship between the middle term and the last term. All right, let's have a look at that. Last term is half the middle term squared. So our middle term is positive 6x. You take half of that and you square it, and we get this positive 9. All right. Keeping that idea in mind, let's find a value for the last term that will make the following perfect square trinomials. So what value can I add to this x squared plus 14x to make it a perfect square trinomial? Well, recall this relationship. Take half the middle term and square it. So half of 14x is 7. 7 squared is 49, so I'm going to add 49. And if I factor that, I get x plus 7 all squared. Let's try the next one. Half of 7 would be 7 halves. You square 7 halves, you get 49 quarters. And if you factor that, you get x plus 7 halves all squared. And the last one here, let's see if I can move that down for you. We take half of 3, which is 3 halves. You square it, you get 9 quarters. So you add 9 quarters, and then we factor that as x minus 3 halves all squared. All right, keeping this idea in mind, we're going to solve the following by completing the square. Okay, so to complete this square, we want to make the left side into a perfect square trinomial. So exactly what we just did last slide, we take half of -7, which is -7/2, and we square it. So we add 49/4, and whatever we do to one side of the equation, we must do to the other side of the equation. So we're going to add 49/4 to both sides of this equation. So I can now factor x squared minus 7x plus 49/4 as a perfect square trinomial. And that factors as x minus, the square root of x squared is x, the square root of 49/4 is 7/2, all squared. We develop this perfect square trinomial by adding 49/4. On the other side, then we've got -44/4, add 49/4. So the left side of this equation, I'm going to find the value for x by taking the square root of both sides. Remember, anytime you take the square root, you have to include the plus and minus. -44 plus 49 is a positive 5/4. So x minus 7/2 would equal plus or minus. There is no square root of 5, but there is a square root of 4, which is 2. And I'm going to add 7/2 to both sides of this equation. So I have plus or minus radical 5/2, add 7/2. So in simplest terms, this is going to be 7 plus or minus radical 5, all divided by 2. That's the solution for this quadratic equation. We couldn't factor it. If you recall from last slide, we couldn't factor it. We couldn't isolate the x squared term or the x term. But if I make it a complete perfect square trinomial, I can complete the square, and we can solve for x. So we're going to do it again. The next one here, let's isolate the variables on the left side. 3x squared plus 18x, minusing 2 from both sides of this equation. Note, in our first one, we had a coefficient of 1 in front of the x squared term. We need that again. So I'm going to factor out the 3. That leaves x squared, add 6x. And now we're going to complete the square on the left side. Half of 6 is 3. So we take half the middle term and square it. 3 squared is 9. We add 9 to this side. And whatever we do to one side, we do the other. So I would add 9 times 3. Notice there's a 3 here, so I should go 9 times 3 added to the other side. That's 27. So the left side of this equation I can factor as a perfect square trinomial, x plus 3 all squared. The right side I simplify, that's 25. Divide both sides by this 3. We get x plus 3 all squared is going to be 25/3. I take the square root of both sides now, remembering to include the plus and minus. And then I'm going to minus 3 from both sides. -3 plus or minus. Square root of 25 is 5. There is no square root of 3. So this is an acceptable solution, but we usually don't like having a radical in our denominator. So if you recall how to rationalize a denominator, we're going to take 5 radical 3 multiplied by radical 3 over radical 3. That's the value of 1. Radical 3 divided by radical 3 is 1, so we're going to change the form. So 5 times radical 3 is 5 radical 3. Radical 3 times radical 3 is just 3. That allows us to simplify the solution. Instead of -3, then I'm going to write this as -9/3 plus or minus 5 radical 3 over 3. So I now have a common denominator of 3, and I can write this as a single expression, -9 plus or minus 5 radical 3 all over 3. So this is a fine solution, but if we rationalize the denominator, there's the best solution. All right, let's try a couple more. A half x squared plus 3x equals -1. Again, step 1, I want to factor out the 1/2. So 1/2 divided by 1/2 leaves me 1x squared. 3 divided by 1/2 is 6. And again, I take half the middle term. So half of 6 is 3. 3 squared is 9. I add 9 to the left side. I must add 9 times 1/2, or 9/2 to the right side. I can now factor my perfect square trinomial as x plus 3 all squared. And negative 1 is the same as negative 2 over 2, so I'm left with negative 2 halves plus 9 halves, which is 7 halves. Now the opposite of multiplying by half is dividing by half or multiplying by 2. So I multiply both these sides of these equations by 2. I get x plus 7 or x plus 3 all squared equals 7. Now I can take the square root of both sides. Don't forget the plus and minus. And I'm going to subtract 3 from both sides. There's a solution to this quadratic equation. Last one then. 2x squared plus 16x plus 24. Again, let's isolate the variables on one side of the equation. Let's factor out the 2, so I've only got a coefficient on the x squared term of 1. I take half our middle term, half of 8, which is 4, and I square that, so I add 16 to the left side, and I would add 16 times 2, or 32, to the right side. Keep my equation equivalent. I would now factor my trinomial perfect square as x plus 4 all squared, and that will equal 8. I will now divide both sides by 2 and take the square root of both sides, remembering again the plus and minus. And I can now subtract 4 from both sides, plus or minus the square root of 4, which is 2. And this works out to be two exact solutions that are integers. Negative 4 plus 2 is negative 2, or negative 4 minus 2 is negative 6. What that tells us is we could have factored this equation, but completing the square still works. All right. Well done. What I'd like you to try then are these questions. We're going to work on these in class tomorrow. We'll see you then.